Hi, good morning. This is Srinivas Aluwala working as Assistant Professor in the Department of Computer Science and Engineering, SR Engineering College, Warangal, Telangana, India. Welcome to the presentation on OSI model. Before we start the OSI model, let us know the course objectives. Course objectives are understanding layered architecture, network architecture for data communications, understanding the functions of all layers in the OSI model. At the end of the presentation, the course outcomes are the students will be able to understand the importance of layering in data communication, knows the basic functionalities of OSI model and their implementation in layered architecture. OSI model, Open Systems Interconnection Model, is a set of protocols that allows two different systems to communicate regardless of their underlying architecture. The purpose of the OSI model is to show how to facilitate communication between different systems without requiring changes to the logic of the underlying hardware and the software used. The OSI model is not a protocol, it is a model for understanding and designing a network architecture that is flexible, robust and interoperable. The OSI model architecture comes with the 7 layers. They are the application layer, presentation layer, session layer, transport layer, network layer, data link layer and physical layer. Every lower layer provides services to their upper layers in the OSI network architecture. And before we move on to seeing the basic functionalities of each and every layer of the OSI model, let us see an exchange of data using the OSI model. The exchange of data in the OSI model takes place when the application user submits the data to the application layer. Application layer takes the data, assigns a header to the data and gives it to the presentation layer. Presentation layer takes the data from the application layer and assigns it an header, an application header. Then it gives it to its lower layer, that is the session layer. Session layer takes the data from the presentation layer and assigns an header of the session layer and then gives the data to the transport layer. Transport layer takes the data from the session layer and assigns a transport layer header and then gives the data to the network layer. Network layer takes the data from the transport layer, assigns a network layer header and gives the data packet to the data link layer. Data link layer takes the data from the network layer and assigns a data link header and a trailer to the data packet and gives that packet or the frame to the physical layer. Physical layer takes the data from the data link layer and assigns a physical layer header and converts the data into bits of streams, and those bits of streams are going to be sent or transmitted by making use of a transmission media which is available between the two different systems. And then the data is going to be reached to the receiver end. Receiver end architecture does the same thing in the vice versa as it has been happened at the receiver end. This is how an exchange of data takes place using the OSI model network architecture. Layers in the OSI model. Now we briefly comes to know about the functions of each layer in the OSI model. Firstly, let us go for seeing the basic functionalities of the physical layer. The physical layer coordinates the functions required to carry a bit stream over a physical media. It deals with the mechanical and electrical specifications of the interface and transmission media. The physical layer is also concerned with the physical characteristics of the interfaces and medium. The physical layer defines the characteristics of the interface between the devices and transmission media. It also defines the type of transmission media. Physical layer, although deals with the representation of the bits, the physical layer data consists of stream of bits. They are sequence of zeros or ones with no interpretation. The physical layer is responsible for the movements of individual bits from one hop to the next. Physical layer also concerned with the data rate, The transmission rate, the number of bits sent each second, is also defined by the physical layer. And it also concerned with the synchronization of the bits. The sender and the receiver not only must use the same bit range, but also must use the synchronized at the bit level. And it also tells the transmission mode, defines the direction of transmission between two devices, that is maybe a simplex, half duplex or full duplex. And now coming to the data link layer, as the data link layer takes the data frame packet from the network layer, and the data link layer transforms the physical layer, a raw transmission facility, to a reliable link. It makes the physical layer appear error-free to the upper layer, that is the network layer. The other responsibilities of the data link layer are framing. The data link layer divides the stream of bits received from the network layer into manageable data units called frames. Data link layer also takes up the basic responsibility of physical addressing. If the frames are to be distributed to different systems on the network, the data link layer adds a header to the frame to define the sender or the receiver of the frame. If the frame is intended for a system outside the sender's network, the receiver address is the address of the device that connects the network to the next one. It also takes the responsibility of flow control. If the rate at which the data are absorbed by the receiver is less than the rate at which the data are produced in the sender, the data link layer imposes a flow control mechanism to avoid overwhelming the receiver. It also takes the responsibility of the error control. The data link layer adds reliability to the physical layer by adding mechanisms to detect and transmit damaged or lost frames. The data link layer is responsible for moving the frames from one hop to the another hop. If at all you look at the picture, we can know how the communication is made at the data link layer. At the receiver end, A is the sender, B is the receiver. At the receiver end, the frame starts at the node of the receiver A and reaches to the intermediate node with the data frame along with an header, and from the next intermediate node it again carries forward to the next intermediate node which is in the path of the destination, and this carries out until the frame is reached to the data link layer of the receiver. Now coming to the network layer. Network layer takes the data segments from the transport layer. It is responsible for the source to destination delivery of a packet. At the network layer level, we call the data as the packets, possibly across multiple network links, whereas the data link layer oversees the delivery of the packet between two systems on the same network. Coming to the network layer, it ensures that each packet gets from its point of origin to its final destination. And the network layer takes the responsibilities like logical addressing, routing. Logical addressing, coming to the logical addressing, the physical addressing implemented by the data link layer handles the addressing problem locally, that is within the same network. If a packet passes the network boundary, we need another addressing system to distinguish the source and the destination systems. And this is taken up by the network layer, which adds a header to the packet coming from the upper layer. It includes the logical addresses of the sender and the receiver. Coming to the routing, when independent networks or links are connected to create an internetwork or network of networks, route or switch the packets to their final destination. One of the functions of the network layer is to provide routing mechanisms. And here we see how the communication is done at the network layer. As the data packet starts from the sender and moves to the destination, that is the B receiver here, which is starting with the network layer of the sender and reaching out to the network layer of the receiver, passing through all the intermediate nodes which are available on the way to the destination. Coming to the transport layer, transport layer takes the data from the session layer and is responsible for process to process delivery for the entire message. A process is an application program running on a host, whereas the network layer looks for source to source or source to destination delivery of individual packets. Other responsibilities of the transport layer are service point addressing. Computers often run several programs at the same time. For this reason, source to destination delivery means delivery not only from one computer to the next, but also from a specific process running on one computer to a specific process running on the other computer. The transport layer header must therefore include a type of address called as service point address, also called as port address. The network layer gets each packet to the correct computer. The transport layer gets the entire message to the correct process on the computer. And the transport layer, it also takes the responsibility of segmentation and reassembly. A message is divided into transmittable segments, with each segment containing a sequence number. These numbers enable the transport layer to reassemble the message correctly upon arriving at the destination and to identify and replace packets that were lost in transmission. And it also takes the responsibility of connection control. The transport layer can be either connectionless or connection oriented. A connectionless transport layer treats each segment as an independent packet and delivers it to the transport layer at the destination. A connection oriented transport layer makes a connection with the transport layer at the destination machine first before delivering the packets. After all the data transferred, the connection is terminated. The transport layer is responsible for delivering the message from one process to another process. Looking at how the message is going to be delivered from a process to the process, looking at the picture, we can go for understanding. On a single computer, n number of processes running, and a specific process wants to communicate with a specific process on the receiving end. As we look at the picture, as network layer takes the responsibility of delivering the data from host to host, and coming to the transport layer, it takes the responsibility of delivering the data to a process delivery. That is, a specific process running on a computer need to send or submit its data to a specific process running on the other computer at the receiver end. And now look at the communication at the transport layer. As we have seen in the previous examples, the sender's message starts at the transport layer of the sender, and then it goes on moving to the network layer, data link layer, physical layer of the sender, and goes through the intermediate nodes as passing through the physical and the data link layers to all the intermediate nodes until it reaches to the sender's destination. When it reaches to the destination, the data is going to be submitted to the physical layer, then to the data link layer, then coming to the network layer, and then finally it is going to be submitted to the transport layer. And this is how the data is going to be passed from a sender to the destination receiver. The unit of communication at the transport layer is segment. Generally, when we see the units or the data called at each layer is going to be different. The unit of communication at the transport layer is a segment, user datagram, or a packet, depending on the specific protocol used in the layer. Now coming to the session layer. Session layer provides the services to all the three layers. Services provided by the first three layers, physical, data link, and networks, are not sufficient for some processes. The session layer is the network dialog controller. It establishes, maintains, and synchronizes the interaction among communicating devices. The session layer is responsible for dialog and synchronization. The specific responsibilities of the session layer are dialog control. What is dialog control? The session layer allows two systems to enter into a dialog. It allows the communication between two processes to take place in either of the communication modes, that is, one way at a time or two way at a time. In other words, it's half duplex or full duplex. And the session layer also takes the responsibility of synchronization. The session layer allows a process to add checkpoints or synchronization points to a stream of data. For example, if a system is sending a file of 200 pages, it is advisable to insert checkpoints after every 100 pages to ensure that each 100-page unit is received and acknowledged independently. In this case, if a crash happens during the transmission of page 523, only the pages that need to be sent after system recovery are pages 501 to 523. Previous pages to previous to 501 need not to be resent, and which looks a great responsibility of the session layer in the data communications. Now coming to the presentation layer. Presentation layer is concerned with the syntax and semantics of the information exchanged between two systems. It takes the data from the application layer and it has the responsibilities like translation, encryption of the data. Translation, the processes in two systems are usually exchanging information in the form of characters, strings, numbers, and so on. The information must be changed to bit streams before being transmitted. Because different computers use different encoding systems, the presentation is responsible for interoperability between these different encoding methods. The presentation layer at the sender changes the information from its sender dependent format into a common format. The presentation layer at the receiving machine changes the common format into a receiver dependent format. And it also takes the responsibility of the encryption. To carry sensitive information, a system must be able to ensure privacy. Encryption means that the sender transforms the original information into another form and sends the resulting message out over the network. And at the receiver end, decryption reverses the original process to transform the message back to its original form. And it also takes the compression responsibility. Data compression reduces the number of bits contained in the information. Data compression becomes particularly important in the transmission of multimedia such as text, audio, and video. Communication at the application layer. Starting at the application layer of the sender, application layer, transport layer, network layer, data link layer. The data communication or the data sending starts at the application layer of the sender and it reaches to the application layer of the receiver, going through all the responsibilities of the network architecture layers of the OSI model. Now coming to the summary of the application layer, summary of the OSI layers. Application layer, it allows access to the network as it enables the user, whether human or software, to access the network. It provides user interfaces and support for several devices such as electronic mails, remote files, accessing shared database management and other types, distributed information, etc. And coming to the presentation, as we have seen the basic responsibilities of the presentation layer, it translate, encrypt and compress the data. And next to the session, it establish and maintain the termination and establishment of the sessions between different systems. Transport layer, it provides reliable process to process managed message delivery and error recovery. The simplest way of the network layer summary, it moves the packets from source to destination to provide inter-networking. Data link layer, it organizes bits into frames, it provides hop-to-hop delivery. And coming to the physical layer, the downmost layer of the OSI model, it takes the responsibility of transmitting bits over a media to provide mechanical and electrical specification. And this is the brief summary of all the layers of the OSI model, Open Systems Architecture, Open Systems Interconnection Model.